Hello everybody and welcome back to another OpenGL stream. Done a lot of these in a row. Today we're going to be doing some cleanup and organization, I just muted that, of our existing classes and code. This will make it a lot more readable, and it will just reduce the amount of clutter that we have in our main class, and pretty much just make it a lot easier to read. Hold on, let me just reload this. Okay, so let's go ahead and get started. So the first thing I wanted to do was go into bounds H and look at the enum class that we made for the types. Oh, okay, that's good. So instead of just having it as enum class bound types, this actually defaults it to an integer size. So this actually takes up, each of these takes up 4 bytes. And as a result, this thing will take up 4 bytes. Now this is a problem if we have a lot of bounding regions, and we will for each of our meshes. So as a result, what we want to do is force this enum class to become an unsigned integer. And the way you do that is you just put a colon and then unsigned char, actually, not an unsigned integer, unsigned char. So as a result, this will become 1 byte, and we can actually check that out here. Standard cout size of bound types, and let's say the box. So if we run this, we should just get a 1, and we do. All right, so that's all good. All right, so today we're gonna start off by making a formal class for our memory objects. So this includes our buffers, the vertex buffer and the element buffer, and then also our vertex array. So in the graphics folder, I'm gonna go ahead and create a new file called glmemory.hpp. And I'm doing an HPP file because we will use templates, and templates don't really work in separate files, so that's all. So it's just going to be glmemory.hpp. So in here, I'm going to go ahead and start by with our macros. So we're going to say if not defined, glmemory hpp, define glmemory hpp, and then end if. Hold on, let me just turn this down just a notch. All right. Oh, no, not that. I did not want to show that. Okay. So, and then after this, we're going to include our glad stuff. So just the basic glad/glad.h, and then include glfw/glfw3.h, because we will be using the memory setting methods, the GL buffer data, all that good stuff. And then also we want to include map, because we will be needing that for this. All right, so the first one we're going to do is we are going to create a class for buffer objects. So this will be our VBOs, our EBOs, etc. So it's going to be class, and I'm just going to call it buffer object. You can call it BO for body odor if you want, but I'm just going to leave it as buffer object. We're only going to have public values, and the 2 actual values in this class are going to be an integer and then an enum. One is going to be the location, so the integer value of it, which will, like the location in the memory, and then there's an enum for the type of it. So we're going to say value/location, and that will be a GL uint for GL unsigned integer, and it's going to be val. And then we're going to say the type of buffer, and this can either be a GL array buffer or a GL element array buffer, etc. So we're going to say GL enum type. Next, we want to have a default constructor. So buffer object oh, I forgot to capitalize the L there. So the default constructor is going to have nothing in it. Then we're going to have you initializing it with a type, so buffer object, and then you pass in a GL enum type. And then in here, all we want to do is just initialize type as type. All right, just like that. Next, we're going to have a generation method, so generate object, and this will be void generate. And then we will say GL gen buffers 1, and then a reference to val. So if you remember when we were doing our VAOs, VBOs, all that stuff, when we said GL gen buffers, we had to pass a reference to the actual locate out to the integer, unsigned integer value of it. Just like that. And then we have to go ahead and have a method to bind the object. So I'm essentially just outlining the process of using this memory. But the thing is, now we don't have to actually call all the OpenGL methods from the class. We can just call these methods, which I guess you can kind of say it makes it a little easier to look at. All right, so we're going to say void bind for binding, and then that's just going to be GL bind buffer. And now we're going to use that type parameter. So this is why we had type in there. So type and val. Next, we're going to have a template method. This will be to set the data. This will be with GL buffer data. So we're going to say template, and then in the chevrons or triangle brackets, we're going to say type name t, and then void set data. And we're going to pass in a GL uint for the number of elements, a pointer to the data, which will be t, so t star data, and then GL enum usage. And in here, all we're going to say is we're going to call GL buffer data, and we are going to pass in type. And then to get the size of the data that we're passing in, all we have to do is multiply the number of elements times the size of t. So we're going to say number of elements times size of t. Now the reason why I didn't just make this a parameter itself is because the size ofs, they got lost in passing it as a parameter, or something got lost at least. I don't know why, but when I was testing it, this is what worked. And it also kind of makes it look a little better on the eyes and easier to read. Next, we're going to say data, which is just the pointer to the data, and then usage. So that's a one-line method there. Next, we're going to have the method for updating data. So this is where our instancing stuff comes in with our model arrays, where something is moving, or there's going to be a lot of instances, and those instances are either updating, so they're changing location like the balls, or we're adding or subtracting instances like with the balls and then the boxes as well. So we're going to say update data here, and we'll be using GL buffer sub data here. So all we're going to say is void, or template actually, so template and type name t. We're going to say void update data. We're going to pass in a GL int pointer offset, GL uint number of elements, and then t star for data. I'm getting the GL int pointer, that's just from the method definition, that's just the type there. It's usually going to be 0 though. So we're going to say GL buffer sub data, and we're going to pass in type, offset, number of elements times size of t, like above, and then the data, just like that. All right, so that is updating the data, and now we're going to have a method to set the attribute pointers. So this is going to be with GL vertex attribute pointer, and what we did with the mesh class. So that's going to be all of these. All right, so we're going to say set attribute pointers. This is also going to have to be a template type name too. So the reason why I'm doing templates here is because the data that we pass in is not always a float. It's not always an integer. Like with the EBOs, it's an unsigned integer. But with our VBOs, we're passing in a struct, which is a vertex. And I think this is where I was getting the memory loss. If you cast something to... I was trying to cast it to a void star, but I don't think it liked that for some reason. But anyway, I'm just using templates just because that's what worked essentially. So for this method, we're going to say void and then set at pointer, and att just for attribute. We're going to say pass in an index, so gl uint idx, gl int size, gl enum type, unsigned int stride, unsigned int, or you know, we can say gl uint there. So gl uint stride, gl uint offset, and then gl uint divisor. So divisor is going to be used in instancing, and we'll default this to 0 because we won't be instancing for everything. Like with the mesh here, with our troll, for example, we don't instance that, so that we won't even set the divisor because it'll just be defaulted to 0. All right, so here we're going to say gl vertex attrib pointer. We're going to pass in the index, the size, so the size is just the number of elements. We're going to say gl type first, and then gl false for normalize. And then for the stride, we're going to say, remember, stride is not just number of elements, it's actually in memory, so number of bytes. So we're going to say stride times the size of t. And this is another reason why templates come useful here, because we can actually call size of vertex, and that would give us whatever 8 times the size of float, so 32 bytes. And we wouldn't have to call size of the item that's passed in. And that wouldn't even work here. So we would have to pass in a size of, which I don't know, something was getting lost, but it may have been that, may have been the data, the void star pointer, I don't know. And then finally, we're going to say void star for the pointer, and that's just going to be offset times the size of t. Did I even put offset? I did. Yeah, so offset is the number of or the size in bytes away from the starting element that we away from the starting element that we pass into GL buffer data. All right, next we have to enable the attribute pointer. So GL enable vertex attribute array, and we just pass in the index. And then now we want to do the divisor if instancing. So if divisor is greater than 0, we're going to instance. So we're going to say reset the IDX attribute every divisor iteration. So this is an instancing. So all we're going to say is GL vertex attrib divisor, and we're going to pass an index and divisor. So that's simple. I'm essentially just transferring all the code into one central location, so we don't have to be calling GL vertex attrib pointer so often, because this method is kind of confusing, and it kind of messes up the flow of the code, because you have all these void star pointers in there, and that kind of doesn't, I don't really like it that much. All right, finally, we're gonna have a method to clear the buffer objects. So clear buffer objects, and by clearing I mean binding 0. So we're gonna say void clear, and all it's gonna be is GL bind buffer, and then we're gonna pass in the type and 0. So this method is used when you don't want to have a certain VBO bound anymore. So once we're done loading in data, we unbind it and free that memory up in the GPU. And then finally, we're going to have a cleanup method. So this will be the deletion of it. So cleanup, we're going to say void cleanup. And all we're going to say is GL delete buffers, and we pass in 1 and then a reference to val. All right. Oops, all right. All right, so that's the buffer class, and now we're going to get into the array objects class. Hold on, there's a... Let me just go close my window real quick. I'll be right back. So the process for the array object is going to be relatively similar, actually. It's going to be pretty much just copying and pasting code. So we're going to say structure or class for array objects. So this will be the VAO. So we're going to say class array object. We're only going to have public stuff in here too. We're going to have a value / location, and that'll be another GL uint. But then also what we're going to do is we're going to have a map. And this map will store the buffers that this VAO pertains to. So I explained this very well when we actually talked about the VAOs and the VBOs, because I hadn't learned it at that point. But essentially, when you bind a VAO, or in modern OpenGL, what happens is you bind a VAO, and then everything you do to a buffer object while that VAO is bound, then if you call GL bind vertex array object when you're drawing, OpenGL knows to go to those buffers that you performed operations on while that certain VAO was bound. So that's why we don't have to bind the individual buffers every time we call draw. So that's just modern OpenGL. So we're going to have a list or a map of names to buffers. So we're going to say standard map, and we'll have a const char star as the name, and then a buffer object as the value, and this will be buffers. Okay. So one cool thing that I wanted to do with this class was actually override an operator. So instead of calling VAO.buffers and then passing the name, we can just call VAO at using the square brackets. So we're going to say get buffer, and we're going to return a reference to buffer object, or buffer object, and then the ampersand as a reference, and then we're going to say operator, and then the 2 square brackets. So this overrides the operator. So override the square brackets, and we're going to pass in a const char star key, and this will essentially just return buffers at key, just like that. All right, next method is just generating the object. So generate object, and we're going to say void generate. Here we're going to say glgen vertex arrays, and we're going to pass in 1 and then a reference to val. We're going to have binding just like in the buffer object. So we're going to say void bind and GL bind vertex array, pass in val. This is just like what we did when drawing the meshes, so that we're going to call that right here. And once again, that will give us access to all the buffers that this VAO has, essentially. Next, we're going to have a cleanup method, so cleanup. And instead of only cleaning up the VAO, what I wanted to do is delete the VAO1, but then also delete all of its children, so all of the buffer objects that are under this VAO. So we're going to say GL delete vertex arrays, and then 1, and then a reference to val, and then we're going to iterate through each of the pairs in the buffers. So we're going to say for auto reference pair in buffers, we are going to say pair.second.cleanup, and that will call this method right here, void cleanup. And then next we're going to have a clearing method, just like the buffer object, but instead of having it as a member, I'm just going to have it as a static method, because there's no type that's specific to, there's no type over here that's like with the buffer you had a type, either array buffer or element array buffer, so it's going to matter what you say when you clear. But here we're just there's no type that you have to pass in, so we're going to say clear array object, and that's just going to bind 0. So I'm going to say static void clear, and all we're going to say is GL bind vertex array and pass in a 0. All right, so that's GL memory, and now we get to implement it actually, which is pretty fun. So we're going to get rid of a lot of these calls over here to GL methods, and that's going to kind of be abstracted into this class. So first go into mesh.h and include this class here. So we're going to say include glmemory.hpp, and then in mesh.cpp we're going to start, where do we want to start? I'll just go from the top to the bottom. So in mesh render, because that's the top method for me at least, I'm going to replace GL, or I'm actually just going to comment it out so I know that so I can just quickly replace it if something doesn't work. So we're going to say VAO.bind. Or, oh wait, we actually don't have a VAO. So we have to go into mesh.h. I just need to, I forgot about this. So in mesh.h, what we have to do is we have to change the unsigned in VAO to an array object. So array object VAO. And this is going to give us a bunch of errors in mesh.cpp because you can't pass an array object as an unsigned integer in OpenGL. So here in render, we're going to say VAO.render, or .bind rather. And then we're going to, after we call the draw elements, we're going to say, we're going to call the static method array object : clear. So this is where that static method comes in. Okay, now we can actually get into using this stuff, and it's not going to be too much. So for cleanup, I'm actually going to move this method down. So for cleanup, all we have to do is just comment this stuff out, and then just call VAO.cleanup. And remember, this will clean up all of the children buffers, and we'll be creating those right now actually. So what I want to do is I'm just going to comment everything out in the setup method because none of it applies right now. We're going to be essentially replacing all of it. All right, so we're going to start by binding the VAO. So we're going to say VAO.generate and then VAO.bind. And now after this, everything that we do with buffers will be bound to this VAO. So we're going to say, we're going to start with the EBO. So we're going to generate /set EBO. So we're going to say, we're going to use our map now. So what we're going to say is VAO at EBO is equal to buffer object, and then we're going to pass in the type as GL element array buffer. So what I did here was I gave it a name, EBO, but the reason why I can say equals is because in the method, when we override the operator, we're returning a reference. So this is a modifiable value. We looked at this in the JSON stuff too, where I was beating myself in because I forgot to pass a reference of an object when overriding the square brackets operator. So this makes it essentially overridable, and we're just setting it to a buffer object. So now we want to generate it, bind it, and give it data. So what we're going to say is VAO at EBO dot generate, VAO at EBO dot bind, and then we're going to set the data. So VAO at EBO dot set data, and we have to pass in a template. So we're going to say GL uint, and then for the parameters, it's going to be indices dot size, a reference to indices at 0, and then GL static draw. So now we look at this, we only have 3 parameters here. Well, I mean technically 4 if you count the template, but we only have 3 parameters, and this does look a little nicer to look at, I won't lie, because we don't have all these GLs in the way. So we know what we're actually modifying. We know that this is the EBO that we're modifying right here, because it's in all 4 lines. All right, next we're going to do the vertex buffers. So generate /set VBO. So same process, we're going to say VAO at VBO is equal to buffer object, and we're going to pass in GL array buffer because that's the type. VAO at VBO dot bind, or generate rather, then VAO at VBO dot bind, and then we're going to set the data now. So VAO at VBO dot set data. And this time we're going to pass in a type of vertex, because that's, if you look up here in the original calls, we pass in size of vertex at vertices, reference to vertices at 0. So the types are all vertices here. So we're just going to use that structure too, and that size will carry over as well. So the size of a vertex is once again 32 bytes, because it's, yeah, 32 bytes because it's 8 floats. So what we're going to say is for the data, we're going to vertices.size, a reference to vertices at 0. And this is another reason where the template comes in, because we would have to cast that to a void star otherwise. And then we're going to say GL static draw once again. Okay, now we can set our vertex attribute pointer. So set vertex attribute pointers. And notice how the VBO is already bound. So we don't have to rebind it again. We can just go straight into setting the pointers. So we're going to start with the vertex positions. So we're going to say VAO at VBO dot set at pointer. And this time they're all going to be GL floats. So GL floats. Index is 0, size is 3 because it's a GLM vec3, and then type is GL float, and then stride is going to be 8 floats, and then a 0 for the divisor. Or we actually, no, that 0 is the offset rather. Next we're going to do the normal array. So VAO at VBO dot set at pointer, GL float for the template parameter, index 1, size is 3, and then GL float, stride of 8 and offset of 3. And then for the texture coordinates, we're going to say VAO at VBO dot set add pointer. The type is GL float once again. Oh god, my dog. Give me half a second. I will be right back. Try and figure out what that is actually. Give me a minute. I'm back. That was probably ear rape right there. Just knocked my mic. Okay. So for the parameters here, we're going to say 2 for the index, 2 for the size, because the texture coordinate is 2D, remember? Oh god. Damn it. GL float for the type again, same stride, and then 6 for the offset this time. And then after this, what we want to do is we want to clear the VBO. So we're going to say VAO at VBO dot clear. And then we want to clear the VAO. So all we're going to call is that static method. So we're going to say array object clear. Give me one more second. Sorry. Oh. Alright, Mr. Jack Headroom. Okay, so he'll be back. Okay. So what we can actually do is just test this, I believe. because it doesn't, because we haven't touched anything else. This hasn't changed any outside functioning. So what we can do is just test this. So let's run it and see if it works. Oh, and of course we got an error. Oh, yeah, okay. Okay, so the one thing that we are going to have to, just so they said that, it does actually affect a couple of things just in the model array, because we do call OpenGL methods here. So, oh, we are going to have to change the model array. Yeesh, okay. You know, let's just do that right now quickly. It's pretty much the same sort of same procedure, really. But instead of having a dedicated VAO for this, we're going to have to create a separate VBO as its own object, its own buffer object, because we're going to be applying it to several different VAOs for each mesh here. So in the model array class, what we have to do is change the pose VBO to a buffer object type, and also the size VBO as well. So buffer object there. Okay. So we should be getting a couple of errors because the type is a mismatch. So let's go ahead and let's just start this procedure all over again. So I'm going to comment this stuff out individually. Okay. So for the position VBO, we're going to say pose VBO is equal to a buffer object. This is why we needed the default constructor, because this is not initialized, so it would give us an error because it can't find a constructor to initialize it with. So we're going to call this a GL array buffer. Then we're going to say pose VBO dot generate, same procedure, pose VBO dot bind, and then pose VBO dot set data. And this time we're going to pass in a GLM vec3 for the type. So now you may be wondering, what are the parameters? So for the parameters, we're going to pass an upper bound for the number of elements, because remember that's what we're allocating 100 slots of memory, or 100 vector 3 slots. And then next we're going to pass in null for the data, remember, because we don't actually want to set it up with any data yet. And then we're going to say GL dynamic draw. All right, and then it's actually the exact same thing, so I'm just going to copy and paste it for the size VBO, except I'm just going to change the name to size VBO. If you were wondering what wizardry I just pulled there, you can select multiple columns of text using Alt in Visual Studio, so I just did that. I selected the pose in each of them and then just changed it to size. And that's another advantage of making this a class, because in the original stuff, these weren't really aligned all too well. Like you got this vertex attribute array in there, it kind of screws everything up. But this is kind of nutty, I won't lie. Okay, now, I need to... Alright, so now we're going to actually go through each mesh and do the attribute pointer. So it's going to be pretty much the same thing. So what we're going to say is model.meshes at i.vao.bind. And IntelliSense is not working because mesh is model is a template variable, so it doesn't really know that it's a model class, so it doesn't know that the template has a meshes variable in it. So now we're going to say set vertex attrib pointers. Let me just make sure I did it right over here. Yeah, okay. So now we do have to bind the VBOs separately because they're two. We could combine this into one, but that would be, I might say that for later. I don't know, because that's batching your vertex attributes. But we might do that later. So we're going to start with the positions. So we're going to say pose VBO.bind, and then pose VBO.set at pointer. And then we're going to pass in the type of glmvec3. We're going to say 3 for the index, because remember we do 0, 1, 2 for the normal mesh. The size is 3, and then GL float. Just a quick note, the template parameter and this GL float are completely unrelated. This 3, the second parameter, and the GL float are related, because this says 3 of GL float, not 3 of glmvec3. And then we're going to say 1. What is it? 1 for the stride, because it's 1 glmvec3 of the stride. 0 for the offset, and then now we're going to take advantage of this divisor attribute, and we're going to pass in a 1 there, because remember we do want that to reset every instance. I can actually just delete. Should I delete that now? No, I'm not going to. All right. And then we're going to do the same thing for the size. So size VBO.bind, size VBO.set at pointer, template parameters glmvec3. This time index is 4, size is 3, GL float, stride is a 1 3D vector, and then a 0 for the offset because it's its own VBO, and then 1 for the divisor once again because we do want that to reset every instance. Now we can call array object clear, the static method there, once we have finished with this model mesh. All right, now we can, now we get to do the update data as well. So in model array.render, what we are going to say is, I'm just going to comment all of this stuff out here. And I'm going to say, so we have to reset VBO data. So we're going to start with the position. So pose VBO.bind. And you will notice that we don't actually insert these as into the dictionaries or the maps for each VAO, and as a result we will have to clear these individually as well. So pose VBO.bind, and then pose VBO.update data. The type will be glmvec3 again. We're going to pass in a 0 for the offset, and then the data, or the size, number of elements rather, will be instances, that's the name. And then we're going to pass a reference to positions at 0. And then same for the size. So size VBO.bind, size VBO.update data, template parameters glmvec3, 0 for the offset instances, and then a reference to the sizes at 0. And then after this, we just want to clear. So we're going to call size VBO.clear. You can do whichever one, pose VBO, doesn't matter, because those have the same type of the array buffers. Okay, now we get to call the running, or do the running. We get to use these methods in the drawing. So we're going to say model. So further down in the render method, in the for loop, we're going to say model.meshes at i.vao.bind. Oops. And then after that, we want to say array object clear. And then we leave the GL draw elements instance as is. No, I should honestly, we could make this. We could make it, let's just make this a method in the VAO and their array objects. So let's just say, yeah, okay. So in glmemory.hpp, go into the array object class, and I'm going to create a new method to draw. So we're going to say void draw, and in here we have to pass in a couple of things. We we have to pass in a GL enum for the mode, number of instances or number of elements, type, offset, if I'm right. That's not the right thing. I'm going to look up the definition real quick online. GL draw elements instanced. Here we go. All right, so mode, count, type, indices. Okay, yeah. So in glmemory.hpp, we're going to say, I'm just going to copy this so I can just get it, and I'll just pretty much put it in. All right, so GL enum mode, and then we want to say, we're going to say GL uint for the count, GL enum for the type, so that's going to be our unsigned integer. Indices, we're going to say, do I want to do a void star? I don't think I want to do a void star, no, because that's what screwed us up last time. I'll just do a GL int for now, and maybe I'll look at if I can change that later on. And then finally for the instance count, that's just going to be another GL uint. And we're going to default that to 0. Or we'll default that to 1, how about that? Alright, so now what we're going to say is we're going to call, you know, what we can do is we can just call GL draw elements instance, and if instance count is 1, it will just draw it one time, which is what we want for most of our elements. So we're going to say GL draw elements instanced, pass in mode, count, type is type, indices, and then instance count. Yeah, okay. All right, so we are getting an error with this, or oh, we just have to cast indices to void star. That's it. Okay. So now we can actually replace these draw methods here. So what we can say is, you know, what I might want to do is just put the binding inside of that too. You know, no, I'll just leave it out for now. Maybe I'll do that later. So we're going to say model.meshes@i.vao.bind or .draw, and we're going to pass in GL triangles. Model.meshes@i.indices.size, GL unsigned int 0, and then instances. All right, and now that, and then for the cleanup, we just have to add the two buffer objects to clean up. So pose VBO.cleanup and then size VBO.cleanup, and now we should be. I hope maybe you guys heard that, but I have terrible posture, so my back just cracked. Okay, and then we can also replace the draw method in mesh.cpp. So just in here, comment that out and say VAO. So in mesh.render, say VAO.draw, and we're going to pass in GL triangles, indices.size, GL unsigned int, and the indices we're going to pass as 0. And then remember, the number of instances defaults to 1, so it will only render it one time. Alright, let's run this, and ooh, spooky, no errors, and yay, it worked. Beautiful. Oh god, that looked like a set of horns. Oh, the model array works as well. Nice. So that's working too. So we have replaced 2 of the 3 things that I want to change with this class, and the last one is the box. God damn, no, I need to actually start doing stuff. This is taking a while because I still have a lot more that I want to do. Okay, that's done. So we can actually just get rid of all the commented code. Alright, there's that. That. All right, clear. Delete that, that, and then. God, this is like over the hedge when I'm just saying here, and when RJ is diagramming the freaking house. I don't know how many of you guys are gonna get that reference. Jesus Christ, that's an old movie. I need to stop wasting time. Okay, go into box.hpp, and we're just gonna quickly replace all of this stuff as well. Oh, I don't even have it open. That makes it a lot harder. Okay, so in box.hpp, we have to include the GL memory class because we haven't included model.h. So we're going to say include /glmemory.hpp, and then go down to where we have all of our buffer object models, and you can delete everything, the 2 lines with unsigned integers, and just replace it with an array object VAO. And this is going to be one of our the only class where, or as of now, the only I should fix my words. This is going to be one of the classes where everything will be within this VAO, so we won't need an extra two VBOs like we did with the model array. Okay, let's start with cleanup. Simple. So cleanup just becomes VAO.cleanup, and that once again that deletes all of the buffer objects that are contained within the VAO. Okay, so let's go to the top. Right under where we have all our indices, delete everything below that. So the generation of the VAO to the bottom of the method, delete that. This is in the box init method, by the way. So we're going to start with generating VAO. So we're going to say VAO.generate, and then VAO.bind. Generate EBO. So VAO, and then we're going to give it a name, EBO. And remember, this is a reference, so we can just directly assign something to it. So we're going to say is equal to buffer object, type is GL element array buffer, VAO at EBO dot generate, VAO at EBO dot bind. I kind of like to keep these separate just so you know what's happening in the process. I mean, it's not cutting down the lines of code, but it is becoming a lot easier to read. Like the number of lines is pretty much the same thing, but just becoming a lot easier to read as someone from the outside. So I do still want to show that process though. All right, and then we're going to set the data. So VAO at EBO dot set data, and the type is GL uint, and we have data this time, so we're not going to say null. So number of elements is indices.size. The pointer is going to be a reference to indices at 0, and then GL static draw, just like that. And then generate VBO. So we're going to say VAO at VBO is equal to buffer object, and we're going to pass in GL array buffer. VAO at VBO dot generate, VAO at VBO dot bind, damn it, and then VAO at VBO dot set data. Oh, not that pointer. So this data is going to be a GL float, because remember our vertices, we just this copy and paste data that I gave a couple of videos back, I just gave it floats. I didn't save GL and vec3s, so it's just going to be a bunch of floats. So we're going to say vertices.size, reference to vertices at 0, and then GL static draw. And what we can actually do is just set the attribute pointers right now, so we don't have to rebind anything. So we're going to say VAO at VBO dot set at pointer. The type is GL float. Index is going to be 0. Size is 3. GL float. and then stride is 3 floats, and once again we're passing in an integer, and that integer is then converted into byte memory in terms of bytes in this method. And then the offset is also 0, and we don't want it to be we don't pass in a divisor because we don't want this to be instanced. Okay, now we do our position VBO, which is dynamic. So we're going to say VAO at VBO is equal to buffer object GL array buffer. VAO at VBO dot generate. VAO at not at VBO, at pose VBO, because remember it's a new name this time. So that dot bind, and then VAO at pose VBO dot set data, and this time it will be of type glmvec3, and then the number of elements is going to be upper bound because remember we just want to allocate this instanced memory, and we'll update it as we render. And then we're going to say null for the data, and then GL dynamic draw. And once again, we're setting the attribute pointers. Attribute pointers up here just because it's already bound, so we don't have to rebind anything. So we're going to say VAO at. My mouth is getting tired from saying VAO. Pose VBO dot set at pointer. Type is glmvec3. Index of 1 because we already have a 0, and then size is 3, and then that size pertains to GL float, and then the stride is 1. All right, so this I've kind of made it confusing with the types and templates here. So essentially, this 1 here for the stride pertains to the parameter, to the template parameter. This 3 here, that size pertains to the type that we pass in. So these two are bound or are related, and then this and the template parameter are related as well. And then once again, and then we say 0 for the offset, and we want to instance it at 1 every instance, or we want to update it every instance, so we pass in 1 for the divisor. I'm just going to copy this once again for the size because it's pretty much the same. So we're going to say size VBO dynamic, and I'm going to use my little alt key trick to just get all the pose and replace it with size. So that's what you can do with this new structure now. Okay, and then finally we want to clear it. So we're going to say VAO at size VBO dot clear, and that clears the VBOs. And then we want to say array object clear. If you were wondering why I don't clear the EBO, that's just because I was getting an error, like it wasn't rendering any of the elements when I did clear it, so it might be some issue, but I'm not entirely sure about that. I don't really know. Okay. Now we go into render, and we're gonna do our updating data. So we want to update data. So we're going to say VAO. So in box render, and then if the size does not equal 0 in that if block, we're going to say VAO at pose VBO, dot bind, and then VAO at pose VBO dot update, or dot update data, and then we're going to pass in glmvec3 as the type. 0 for the offset, number of elements is instances, and then a reference to positions at 0. That's giving me an error. Oh, because I updated this in the other class. I'm just going to change size to instances. Just to keep that the same, because I think size is it's not in this class, but it was, and I just want to. Size didn't really make sense because we have a size VBO, so it doesn't really make sense. And then the other thing that I wanted to change was make offsets change that name to positions, just so we can kind of keep it consistent with, because the pose VBO we have in the model array, so I just want to keep that name being consistent, and then just change the name in the calculation of instances, so positions.size there. All right, and the same thing for the size VBO, so VAO at size VBO dot bind, and then VAO at size VBO dot update data, passing GLM effect 3, offset is 0, number of elements is instances, and then a reference to sizes at 0. Okay, and then after this we can draw stuff. So we're going to say so render data. So VAO.bind, and then VAO.draw, we can actually call that method. And then so the mode is going to be GL lines. That's one good thing, we get the freedom to call that here. I think I wanted to change that in the mesh class last video, but that would have just made things really complicated. So we do have the freedom to call this in a method now. So lines is that, mode, number of elements is indices.size. The type is GL unsigned int, because that's the element buffer, and then 0 for the indices, and then instance count is instances. Okay, and then finally, this last method here, add instance, just change that offsets to positions as well. So when I change the name to positions of the vector of this list here, you had to change it in 1, 2, 3 other places. Okay, so this should be all good now. Let's just run this, and then it's 11 o'clock, right? Build errors. Oh yeah, offsets. Okay. We can actually make this a method, or we'll leave it for now. Okay. So in the main, you also have to change. We have to clear box.positions rather than box.offsets in the main while loop, because we changed that name. All right. So now let's run it and hope this works. Oh, great. We have more. And then change it. So change every instance of offsets to positions. There's 2 in the main file. They're both in the main loop, which is getting really long, and we're gonna clean the. We're actually going to take a. We're gonna take a Swifter, or no, what? Yeah, Swiffer, which just gets rid of clutter and just massacre this. It's gonna become like 15 line. No, it's not 15. It's gonna maybe actually, I don't know, but it's gonna be shortened very much. Okay. Whew. All right, so now let's run it. Hope this works. Aha. All right, so do the boxes are gone. What happened? Son of a bitch. All right, so I'm just gonna go line by line. So I was running. So when I was testing this code, I was actually running into a couple of errors with the memory stuff. I don't know. So that's another reason why I kind of separated the set data and the bind and the render and bind, just because I thought that if I kind of called them individually, I would be able to pinpoint where the error was coming from, and I found that it was when I was clearing the EBO. So when I found that, I was able to determine that that was where the I just deleted that line and it worked. So maybe if I delete this line, maybe it might be the attribute pointers actually. Nope. Okay, so it's not that. So maybe it is the attribute pointers. So I'm going to try setting the attribute pointers in box all together. So I'll have to rebind. So set attribute pointers. So I'm essentially going to take these 3 lines and I'm going to put them down, but remember you have to bind them first. So VAO at VBO dot bind, and then you can paste the set data or set at pointer method in. Yeah, this method. And then VAO. Oh, I screwed this up, didn't I? Hold on. I screwed the copying and pasting. Oh. All right, and then do the same thing for the other 2 VBOs. So VAO at pose VBO dot bind, and then copy and paste. Oh, that's. Oh no, I just kind of deleted it. That's why. I'm an idiot. No. Hold on. All right, I need to reset real quick because I copied and pasted the wrong stuff. All right, I'm gonna take the at pointers lines, put them down here separately, 6 feet apart for social distancing. All right, and then we want to bind each of them individually. So I'll style this in a second. I just want to make sure this works. It should work. It might have something to do with this, but I don't know. Nope, that didn't do it. Alright, so I was fine with that. So the attribute pointers didn't do anything. Let's see. Maybe I have to bind the VAO here. Oh, I don't clear the VAO down here. So array object clear. Alright, I'm gonna run this, hope it works. No, what's going on? Alright, I'm gonna go through this line by line. Okay. Let me make sure. So VAO is an array object, that's right. So we say VAO.generate, VAO.bind, and then the EBO is equal to buffer object, element array buffer, generate, bind, set data, GLUint, yeah, good. VBO is an array buffer as well. Generate, bind, set the data is GL float. That's right. And then we set the attribute pointer over here. And then the pose VBO, same thing. Array buffer, generate, bind, set the data to upper bound. Yeah, upper bound for the number of element. Yeah, that's 100. Okay, so that's set. Null. And then GL dynamic draw, and then set the attribute pointers. 1, 3 float, 1, 0, 1. Oh, that's why the size VBO was, I set it to 1, the index to 1. Yeah, make sure you set your indices of the VBO attribute pointers properly. So it was reading the sizes as positions, which is, there we go. Okay, so now it works. Okay, so yeah, it's always that stupid copying. It was copying and pasting. So I don't recommend copying and pasting, even though I do it all the time. All right, we wasted 5 minutes. Wonderful. Okay, so that all works, which is bueno. All right, let me see if I can actually delete that and see if this works. Okay, all right, so that works. So the only thing I did change was nothing. So the code that we had was right, except I just miswrote this in, or copied and pasted and forgot to change the index of the size attribute pointer. Okay, so that is that. So we now have a class for memory, which now makes this code look a lot easier to read. All right, I'm going to go ahead and close all the documents but the main file. And now we're going to get into our scene class. So before we actually do the scene class, and that's really important, we're going to do a bitwise state class. So this is going to be, we're going to go maybe even over 2 hours. God damn it. All right, hopefully I can get through this. All right, so I'm going to try and, if you want to know more about the states and the bitwise states that I'm doing, I made a video about this and I linked it in the description. But essentially the reason why we're doing states in bits is because in each boolean takes up a byte, and each unsigned char also takes up a byte, but you can manipulate the individual bits in a byte in an unsigned char, and as a result each 1 0 can be converted to their own states. So you can have 8 states in 1 byte for an unsigned char or an unsigned integer, whereas you can only have a single state in a boolean, which is just true or false, and that takes up a whole entire byte. So we are essentially multiplying we're multiplying the memory by 8 in several spots. But this is really important to save memory, and it's also really cool. It's a nifty trick here. So I'm going to call this file states.hpp, and I'm going to put it in my algorithms folder. Once again, it's HPP because we have templates here. So macros, if not defined, states HPP, define states HPP. All right, and then we're going to say namespace states. I'm going to try. I want to try and explain this as much as possible, but I do want to keep this under like an hour and a half, and it's already been an hour and 10 minutes. All right, so end if there. Okay. All right, so we're going to start with checking a state. So I'm going to be using templates for all of these methods because they can either be an unsigned char or an unsigned integer depending on what we're doing. Most of the time we're going to be using an unsigned integer which has 32 possible states because it's 4 bytes, 32 bits. But an unsigned char has 8 bits because it's a single byte. All right, so template, type name t. I'm actually just going to copy this. All right, so the method is going to be bool is active, returns a boolean because we're just checking if something is active. So we pass in a pointer to t star states and then the integer target. So what I'm essentially saying is the target is the index. So visually, what states is going to look like. So states, let's say is it's some number, right? And that number has a binary representation. Let's just say it's an unsigned char for now. So let's say it's 1001101. So that's 8 bits, single byte. So each of these ones and zeros, those are individual bits. So essentially, the target will be going from the right 0, 1, 2, 3, 4, all the way up to whatever the size is. So what you can do is, once again, I detailed this I went into a lot of depth in the video I linked down below. I would recommend watching that if you want to understand, because I'm essentially just taking code right from there and putting it into these methods. So all you have to do here is you have to bitwise and the states with a shifted number. This is going to sound like alien to you guys who haven't, but I'm sorry, I'm not going to explain this, but watch that video, it'll help. So we're going to say return, and then we're going to dereference states, and then do bitwise and, so a single ampersand, and then we're going to do bitwise and with a 1, and then bitwise shift left, so 1, 2 left chevrons, or 2 less than signs, target. And then we're going to say that is equal to 1 left shifted to target. So I'll explain this one, and then that you guys can kind of get the feel for it. So let's say that target is equal to 6. Therefore, 1, so if 1 is equal to 000000001 in binary, then 1 left shifted by target is equal to this 1 but shifted over 6 times. So we're going to have 6 zeros behind it. So it's going to be 0, 1, 1, 2, 3. So it's going to look like that. So now what we can say is if this, let's take our states here. So this and this, right? I'm actually going to put this below just because that's how I had it. So, oh no, not that, this. So this will return a bitwise and for this. So that returns a 1 wherever both of them are true. It's kind of like a Boolean and, where just ones and zeros is true and false respectively. So there are no overlaps of 1, so it's all going to be 0. But however, if we had checked maybe, let's say the target was 3, so 1 left shift target to 3, so 1, 2, 3 there. So this would be 1, that would be 0. And then here, what this is going to do is it's going to return a 1 there because both of these bits right here are a 1. So it's going to return a 1. And as a result, we're just going to check to see if this is equal to 1 left shifted by target, which is true. So that we just return that value. So that's kind of the bitwise and. Next, we're going to activate a state. So template type name t, void activate, pass in t star states, and then int target. So I'm going to be using a bitwise OR, which takes either one. So if the top or bottom is a 1, it just returns a 1, and it can also be a both. So what we're going to say is we're going to do dereference states. I have to put the dereference there because I was getting errors when I didn't, because it's a template, so it doesn't know if it's actually an integer or something. I think that's why, but I hope that's why. So anyway, we're going to do a bitwise OR, which is just the pipeline next to the slash, the backslash. So bitwise OR equals, and then we're going to say 1 left shifted by target. So I'll diagram this one too. So let's say target was 3. Let's say our states was this, or let's say our target is actually 4 this time. So when we bitwise OR like this, it's going to do either one. So we're going to get this essentially the same thing, but with the 4th state active. And we don't have to test anything because we're just setting that to states. We're modifying the states directly. That's why we pass in a pointer. So this state is now active. All right. Next, we're going to say we're going to uniquely activate a state. So that means that no others can be active. This will be useful for cameras. If we have useful cameras, we only want one active at a time. So we're going to say template type name t. So void uniquely activate t star states int target. And then we're going to do something similar. We're going to say dereference states, and then bitwise and equals 1 left shifted by target. So what this does now is, let's say target is 4, and only one of them can be active. So let's say that the 7th state is active. So this is our active states, and this is our 1 left shifted by target. It's only going to return, oh, what did I do? Oh, this might not actually work. Oh, no, that's not the right one. Oh, what you have to do first is we have to bitwise OR it, and then bitwise AND it with that. So then we have to do this bitwise AND with this. And this will return a 0, 0, 0, 1, like that. So we first activate the state and then deactivate all others. So this will be states is bitwise OR equal to 1 left shifted by target, and then we have to AND bitwise AND equal it. So states bitwise AND equals with 1 left shifted by target. So when we bitwise AND it, we're not checking it because we know that it's active. Since we bitwise OR'd it, we essentially activated it. Or what we can do is actually just say activate, pass in t as the parameter, and then say states is states, and then target, just like that. So we essentially activate the state first. So activate state first, and then deactivate all others. So deactivate others. Okay. Now we're going to have a method to deactivate the states. So deactivate states. So template type name t, void deactivate t star states, and then int target. We're running, oh damn it, this is going to be a long ass video, but whatever, it'll be worth it. Okay, and the code here is going to be states or asterisk states, and then bitwise and equals with the bitwise complement of 1 left shifted by target. So this code means, let me just get this here. Let's say the target is 4, so 1 left shifted by 4, And then when we take the bitwise complement of 1 left shifted by target, that essentially just flips all the bits. So we're going to get a 1, 1, 1, 1, 0, 1, 1, 1, 1, just like that. And then if we bitwise and this with that, let's say the fourth state is active, all of the other states will remain active, because if you and something with 1, you just get the original back. Because a 1 and 1 is 1, but a 0 and 1 is 0, so you just get back the original. However, if you and something with 0, you get a 0, so you're essentially deactivating that state. And then there's also a way to toggle a state, so toggle state. So template type name t, so void toggle t star states. The parameters for all of these are the same, by the way, if you didn't realize that. And then int target. So the code for toggle is asterisk states, and then we're going to say bitwise XOR equals 1 left shifted by target. So let's look at this now. So if target is 4, 1 left shifted by target is that, then our active state is like this, and we want to XOR it. So if another trick with bitwise operators is, if you XOR with 0, you get the original back. If you XOR with if you XOR with 0, you get the original back. But if you XOR with 1, you get the opposite, essentially, because bitwise XOR is essentially exclusive OR, so only one of the states can be true. So essentially what we're saying is wherever only one of the states are true. So this is I have to update this. Hold on, just give me half a second. So let's say this was inactive. We're gonna find all the places where it's a 1 and then a 0. So that's this, and then we're essentially activating that fourth state, which is right here. But notice that none of the others are activated or are changed because we XOR them with a 0. Okay, so that's the states class. Hopefully, I said I wouldn't explain it, but I did. So hopefully, I mean, I think that was, I kind of diagrammed it out, so I think that should be enough. But if you do want a kind of slower or more paced explanation, go to that video. All right, so now let's, okay, I need to take a breath. All right, so now let's do our scene class. So this is the culmination, the absolute just climax. I've just been full throb for a couple of minutes just expecting this. All right, so now we're going to create our scene class, and this will be kind of it's going to replace our screen class. So if you remember, we made a screen class in IO a while back that had a couple of screen properties. We're just going to wipe that clean. We are sending it to the fucking gulag at this point, never to come back. We're replacing it, and then we're also expanding it. So we are adding a lot more. So this is essentially the back-end control. It's going to be our origin for a formal engine. What we've been doing so far in OpenGL is we've been creating a game engine, we've been creating physics, we've been creating rendering methods, we've been adding textures, all that stuff. All of that comes into an engine. Unreal Engine 4 has all of these things. I mean, it's nothing, it doesn't compare to this, obviously, but that's all components of the engine that we have been creating. So now what we're moving towards is a formal engine definition. Like a formal class definition, but for now we're just going to keep it as a scene class, because I've seen it as a scene. The scene will kind of control window, all that stuff. It's not particularly an engine just yet. Just like with the screen wasn't particularly a scene yet. All right, how do you like that? Fuck. Okay, so what we can do is let's just delete the screen files, because they're gonna bog us down. Okay, so in our source folder, we're going to create 2 new files, a header and a source, and here we're actually going to be creating separate files just so there's not too much code in one file, because this is a long thing. So scene.h and then scene.cpp. So let's start with scene.h, and we'll go through the methods or definitions, and then we'll actually write the methods. So we're going to start with our macro. So if not defined, scene.h, define scene.h. And if you were wondering, we are going to be using the Bitwise stuff in this. God damn it, it's hot here. Give me, I'm going to I'm going to reopen that window. It's hot as shit. Hopefully that's enough. Get some actual fresh air. I've just been breathing in circulated fart and sulfuric air for the past hour and a half. Okay. Alright, and then we can do a little end if there. Okay. Alright, so we're going to do our includes first. So we'll start with our glad and glfw. So include glad / glad.h, and then include glfw / glfw3.h. Oh, that's a nice draft right there. The wind is coming in. We are saved. Okay. I bet if someone walked in there and just dropped to the fucking floor. Jesus Christ. I need to take a shower. God damn it. It's been like 14 weeks since I last taken a shower. This quarantine's just really bogging me down. Okay, next include is vector. So include vector. And then we're going to include glm. So glm / glm.hpp. And then we're going to include a couple of graphics files, and then also our algorithm files. So include graphics / light.h. Include graphics / shader.h. And then include IO / camera. God, why does it keep IntelliSense is screwing up? So / camera.h. Include IO / keyboard, and then the mouse as well. So include IO / mouse. And then we also want to do our bitwise stuff. So include algorithms / states.h or states.hpp. All right. I'm almost on my last sip of water. So once we get through the definitions, I'll go get some water and we'll take a minute break or two. All right, we've just been going nuts to butts today. Holy fuck. Yes, I won't be getting to sleep tonight. This is just... Okay, I need to stop distracting myself. Let's get through it. So class scene. So we're going to start with our callbacks. So callbacks. And this is going to be the only callback that we will define in this method or this class will be the window resize. So this was in the screen class as well. So static void frame buffer size callback and glfw window pointer window, and then int width and int height. All right, and then with that we're going to need a couple of things, but we'll define the variables after. Next, we're going to have our constructor. So for the constructor, we're going to have a default constructor because we might not want to initialize values because it's going to be a global variable in our main file. So we don't want to initialize anything then. So we're going to say scenes empty nothing, and then we're going to have scene, and where we pass an int glfw version major, int glfw version minor, and then the window parameters. So const char star title, unsigned int scr width, and unsigned int scr height. Just like that. Now we're going to have an initialization method. So initialization. So bool init, So this will set all our parameters, the callbacks, stuff like that. That's why we needed access to the IO classes as well. All right, now we're gonna have a bunch of main loop methods. So main loop methods. So we're gonna have process input. So void process input, and then float DT. Update screen before each frame. So void update, and then get a new frame up. So update screen after each frame. So void new frame, and that will pretty much be the same as the screen new frame. And then finally, we're going to have a render method. So this will be setting our uniform shader variables, lighting, etc. So this method will be void render, pass in shader, and then we also want to pass in a boolean to tell us whether or not to set the lighting. So bool apply lighting, and this will be false. I'll set the default to true, but this will be false for, say, the lamps, for example, because we don't want calculations for the lights done there. So what this method is the big kicker, because what that's going to do is it's going to take out all of this activation stuff, like in the last video when I found the error where like the shader activation shit. We're now just going to be able to call scene.render shader.activate, and that'll take care of all of this lighting stuff. It'll make it a lot easier. Okay. All right, now we have to have a cleanup method. So cleanup method. That'll just be void cleanup. Now we're going to have a couple of accessors. So this will be allow us to get values. So bool should close. So this is taken directly from the screen class. So should close. Camera pointer get active camera. We'll need that variable or function, and then we're going to have some modifiers variables. So modifiers. So void set should close, bool should close, and then also we're going to say void set window color, and we're going to pass in 4 floats there. So that's when we say screen.clear or whatever, and then we give it the 4 values that we gave it. So this will be float R, float G, float B, and then float. God, it's the backwards alphabet. Wait, that actually is in reverse alphabetic order. Cool. That's really interesting, isn't it? Okay, now we're gonna have a bunch of variables. So let's start with our lights. So we're gonna say list of point lights. So standard vector of point light pointer. So a pointer to a point light. Point lights. Try saying that several times fast. And then we're going to have an unsigned int active point lights. So this is where our bitwise operators in that class or that namespace rather will come into play, because we'll be able to call it on these variables and toggle states, toggle lights, stuff like that. So we'll have the same 2 variables for for spotlights. So list of spotlights. So standard vector spotlight pointer spotlights, and then unsigned int active spotlights, and then the direction lights. So direction light, and this will be a dir light pointer, dir light, and then bool dir light active. I don't know if I actually used that. Did I? You know, we'll just put it in there for now. We might need that at some point. Okay, next we're going to do our cameras, or camera. So we're going to have a vector list, so standard vector, camera pointer, cameras, we're going to have an unsigned integer for active camera. And this will, active camera could be 0. Like if you were in a menu screen, like in a loading screen, you're going to have no active cameras. It's just going to be drawing words and whatever to the screen. So active camera will actually just be 0. And then we're going to have our matrices as well, just so we can quickly access them outside of the class. So we're going to say glm mat, or we'll only have to perform the calculations once per frame, like we already did. So mat for view, glm mat for projection, and then glm vec3 camera pose. And then now we're going to have some protected variables. We'll have a window object first, so glfw window pointer window. Window values. So we're going to have a const char star title, static unsigned int scr width, and these need to be static because the frame buffer size callback is static, so it can only modify a static variable. And then static unsigned int scr height, and then float bg for background force, so background color. All right, and then glfw info. And this will just be int glfw version major and int glfw version minor. All right, now let's, I'm going to go with some more, like I said. All right, so that's the class, and we'll be writing all these methods now. We're actually doing okay on time, but it will be a little long. I'll be right back. Don't worry, boys, I'm back. I just had breaths of air that I've not felt for so long. Alright. I just had to put my le chien to bed. It was a little French there for you. Speaking of that, I just finished my last exam today, which was French. So I am officially done with senior year. Pretty fun. And, I'm looking forward to a nice Zoom graduation. I can't wait to get this is just so funny to think about it. My PDF diploma. It's going to be very fun. All right. All right, so let's actually write this shit now, right? Sounds about right, okay. I'm going to take all these methods and just copy them into a scene.cpp file. Well, first we have to include scene.h. All right, so paste that in there, and then I won't do the class tag on each one just because it's going to take forever. So I'll just do it as we go. All right. So let's start with our callbacks. So go to the top of my reference here. We do have to define our static variables up above, just so the compiler knows that they have a value. So we're going to say unsigned int scene scr width is equal to 0, and unsigned int scene scr height is equal to 0 as well. Alright, and then for the callback, we're going to delete the static keyword and then add our scene class tag there. And all we're going to be doing here is just say GL viewport 0, 0 width height. And then we're going to set the variables. Alright, and then that empty constructor can just be left alone because we don't actually have any code there. But for the actual constructor, we do want to initialize a couple of values first. So the first one is going to be our GLFW version major. Just initialize that as GLFW version major, GLFW version minor. Did I zoom in? I think I zoomed in. GLFW version minor. We also want to initialize the title as title, and then active camera as -1. Okay, and then in the actual constructor body, what we want to do is we want to say scr width or scene scr width is equal to scr width, or we can actually just call that static, like callback actually. So we can just say frame buffer size callback, or no, because the window isn't defined yet, so never mind. So we're just going to say scene scr width is equal to scr width, and scene scr height is equal to scr height. And then we're going to set our window color to our default, so set window color, and that'll be 0.1 float, 0.15 float, and 0.15 float, and 1.0f. So that's the colors that we already had before. Okay, so that's good there. And now let's do init. So init is actually a little beefy, I won't lie. So first thing we have to do is initialize GLFW. So GLFW init. And then we're going to set the version. So GLFW window hint, GLFW context version major, pass in GLFW version major. I'm going to do the same thing for the minor. So GLFW window hint, GLFW context version minor, GLFW version minor. So my goal with these classes is to kind of get rid of all of our calls to GL something. Because these functions, you mainly want to abstract them into different classes like the scene class or the mesh class, buffer object class, stuff like that. And we also want to say set the core profile, so GLFW window hint. This is back code that we wrote forever ago. GLFW OpenGL profile, GLFW OpenGL core profile. You can actually just find all this code in the main file. I'm pretty much just putting the same thing. Okay, next we're going to say if def apple, because they have to be super special here. We're going to say GLFW window hint, GLFW OpenGL forward compat, GL true. Apple just has to be always true, or always special. So they have their little forward compatibility stuff. I don't know. Actually, how does that work? I don't know. I guess you can run it on like a 4, because I think the current version of OpenGL is like a 5, but we're using 3.3. We're back in 1904. But I guess you can run that, whatever. Okay. Now we're going to do our initialize window, and this was the code that was in our screen class. So we're going to say window is equal to glfw create window, scr width, scr height, title, and then null and null. And then we're going to say if window is equal to null, not created. Pretty simple. And then we're just going to return false. And if otherwise, we're just going to make it the current context. So glfw make context current, and then just pass in window. All right. Now we're going to set glad as well. I am very glad to be doing this. So if not glad loader gl loader, that's a really weird method, cast a glfw get proc address to a glad load proc. That's a really weird statement. I don't even understand what that means. So if it's false, standard cout failed to initialize glad blah 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 std and glfw terminate, and then return false. All right, now we're going to go ahead and set up the screen. God damn it, it's an hour and 46. This is getting long. Oh, we have... Oof. You know, I might just save this for the next video, because there's a lot in here. Like, there's a lot. Yeah, this is going to get too long. I'll just finish the init method, and then we won't be able to implement any of this, just because it won't all come together. I want to have like a really just cool climax. I just want to edge you guys just to the fucking edge, to the cliff, and then we'll all just reach that climax together. You know. Fuck. Why do I keep talking? Okay. Anyway, to set up the screen, we want to say GL view port 00 scr width and scr height, like so. And then we want to set our callbacks. So frame size. So glfw get or set frame buffer size callback. Window, and then the frame buffer size callback. Key pressed. glfw set key callback. Window, and then keyboard key callback. And then cursor moved. glfw set cursor pose callback. Window, and then mouse cursor pose callback. Mouse btn pressed. glfw set mouse button callback. Window, and then mouse button callback. And then mouse scroll. Oh my god, glfw set scroll callback. Window, can't even type. This screen is flashing. Mouse wheel callback. All right, so those are just the callbacks that we already have, and then we did have in our screen class. All right, next we have to set our rendering parameters. So set rendering parameters. So this one is depth test. So gl enable depth, oh no, GL enable, and then pass in GL depth test. This just makes sure that doesn't show vertices not visible to camera. So this is going to be like the back of the object. And I think that the way this works is it renders like the furthest back vertices first, and then it renders stuff in front of that. Next, we're going to disable the cursors. So GL set input mode, window GLFW cursor, GLFW cursor disabled. And then finally, we go ahead and return true. You know, let's actually go ahead and implement this just quickly so we don't actually get any errors. So get rid of the screen include. Now you should replace that with an include scene.h. And then we're going to initialize scene up here. So scene, and this is in main.cbp. So at the top of the main thingamajig, at the main function, what you can actually do is just delete everything from glfw init to the shaders. Yeah, to the shaders. So just where we say screen.set parameters, because remember we put that in the scene class now. So we are going to say scene is equal to scene 3 and then OpenGL tutorial for the title, and then 800 and 600. We're actually not going to be able to test this, I don't think. What? Oh, it's inaccessible. Oh, we have to make all this stuff public. Yeah, make sure you put the stuff public in the scene class. And then we want to say if not scene.init, standard cout, or yeah, could not open a window, standard end line, and then glfw terminate, return -1. All right. This stuff is gonna, yeah, okay. We're not gonna be on. You know, I'll just finish up what we can. So let's start at the top at the render loop. So make this while not seen dot shed close, because that's that method. Now we're gonna write that actually before we leave. Make this GLM perspective stuff, just change it to scene dot screen width and scene dot screen height. So scene dot scr, or like scene as in the class scene, and then : scr. What? Oh, it's protected. Oh god. Well, I'm gonna leave you with errors. I'm not doing this. Is getting way too late. I'm gonna start writing wrong, incorrect code. So there will be errors in this. Just FYI. I'm gonna post a video finishing this. Maybe I might stream it. I don't know. If I find time to stream it, I will. But for now, that's pretty much it before I literally fall asleep. On Tuesday, though, I am gonna plan to do something new because I've just been doing straight OpenGL for like the past 2 weeks. So I'm gonna try and do some React Native once again. Go back to that and do a little cool app to fit the theme of the space launches, the space launch that happened last weekend. Yeah, long, hour and 50 minutes. Jesus Christ. Holy shit. All right, well, I have nothing else for you guys today. Stay safe, and I will see you possibly over the weekend, but definitely Tuesday. Yeah, I don't know how to end this. I never know how to end these fucking streams. Yeah, goodbye.